So welcome back to the cLabs Pirate Radio. I'm Anna Rose, the co-host of the Zero Knowledge podcast. And today I'm with two folks from the Polkadot team, Peter from Parity and Alistair from Web3 Foundation. Welcome.
Thanks for having us.
Thank you.
Cool. And I'm really glad I have both of you today because what I want to do is I want to start kind of high level, Polkadot, Kusama, what is that thing? And then I want to dive into some of the deeper tech stuff like XCMP and some bridge interoperability things. Let's start off high level. What is Polkadot?
Yeah, I'll give the high level because I think Al will be able to provide all the backfilling detail that I'm unable to fully define. So Polkadot at a high level is a protocol of protocols. So back when Gavin and Vitalik were trying to figure out what Ethereum 2 was going to look like, there was some disagreement between whether or not sharding, the scalability solution, would be focused on scaling like a single state, or Gavin's view where you should be able to customize each one of these shards for some specific piece of infrastructure, some specific application, so that you can highly optimize that function and then allow that to communicate through an entire network of these optimized protocols within the overall Polkadot protocol.
Could you say like a homogeneous versus heterogeneous
Exactly.
sharded system?
Yes.
Okay.
Yeah. So in Polkadot, you're able to own your own shard, and then that highly optimized, highly customized piece of technology can interoperate, can bridge very seamlessly within the Polkadot ecosystem with other shards. And then also obviously talking about more today, lots of really significant bridging efforts to other chains, because back in 2017, Polkadot was primarily presented as an interoperability protocol, knowing that the world was going to this multi-chain future. It's since evolved since then to also be like a place to host layer one protocols, but the connectivity and interoperability between all those layer one blockchains is obviously paramount to success.
You've used the term shards, but you don't actually call this heterogeneous sharded system like a center with shards. There's other words that you're using for this. And they're actually, presented as standalone blockchains.
Yeah,
in
or
their own right.
Parachain. So like, I think we would call Polkadot's sharding approach a Parachain model. And maybe Al can give a little bit more on sort of like the specific differences in design that is required to get there. But I think that, broadly speaking, this Parachain own your own layer one shard is our approach to sharding.
Yeah, what is then a parachain?
We got there, right? It's a heterogeneous shard, a chain who's part of Polkadot shared security, but which has its own logic.
Cool. So it's like consensus, the proof of stake, is not happening on that individual blockchain. It happens somewhere else.
Well, okay, so some consensus is still happens on the Parachain, but the important thing is that it's Polkadot itself that decides, what's happened on the Parachain, checks that it's correct, and that's really what you mean by shared security. And this has big implications for how chains within Polkadot interact with each other.
Okay, but then execution, like the actual blockchain functioning, that's happening on the parachains themselves, right? I feel like I know the system.
Yes, it happens. It happens on the Parachain. But like so with any blockchain system, everyone who's a node of the Parachain runs a Parachain code. But also with Polkadot, we do something like Ethereum we're playing about with, which is stateless validation. So in fact, all the validators execute the code, even though they don't know the state that it came from. Some validators run the code, check that it was done correctly.
Okay.
Yeah, we were on stateless validation a little bit before Ethereum 2 got really excited about it, because it's like another way to put it, sort of like every, like the relay chain is a light client, right, to all of these parachains. Yeah.
What is DOT then? What is Polkadot? Because what we're talking about here are the parachains, these individual blockchains. They might have their own tokens, their own names, their own ecosystems. But what's Polkadot? What part of this larger network does Polkadot play?
Yeah, so the DOT token has a couple key roles. Obviously, the most significant one is security for the overall network. So like Polkadot, one of the core value propositions for Polkadot long-term is this commoditization of a scarce resource in the blockchain space, which is the economic security necessary to be secure enough to actually trust and use in a production deployment. So when you're a new blockchain, getting to a place where people are going to trust that there's enough economic and technical security behind that chain, it could take you a decade to get to a point where you're like, you know, your chain's worth a couple $100 million or $1 billion, and then people will be like, oh, all right, I'll use this now. With Polkadot, you can buy into broader security that is represented in the DOT token. So the DOT token is used for both staking to secure the network in terms of validation, but also staking or bonding parachains to allow access to the security within the network. So those are the two big ones, and then obviously we can talk a bit about governance, which is
another one
place where Polkadot is, I think, just really pushing.
When you talk about this like economic value as security, I think it's good sometimes to explain what that means. It's sort of like the larger the network value, the harder it would be to 51% or whatever the percent you need to like overwhelm a proof of stake. What is the percentage actually? Is it a 30%, 60%?
So we're aiming for a third.
Oh, a third.
Yeah.
But it's theoretically harder to get a third of DOT tokens than it would be to get 51% of hash power on a proof of work network.
Proof of stake is it's more secure in that way.
Okay.
Because the price goes up when you try to get them.
But so that's the thing is like if you have the value of that central body be high enough, it would be very, very difficult to amass enough value yourselves to actually overwhelm that network and do something to it. And then these parachains can borrow, I guess, that security. They themselves don't have to have, is that true? They don't have to have the same level of value stored in themselves?
Yeah, and a lot of people take this sort of the wrong direction and say, oh, well, like parachains will have less value because you're not using the token for staking. In reality, like, I want to call it a lazy token economic approach, but if you don't need to rely on security dynamics to build a token economic model, you actually have a lot more freedom to design interesting, optimized infrastructure. Al can probably say a little bit more about that, but you know, a lot of networks out there today basically are propping themselves up by the fact that they're a valuable proof of stake token and they don't do really much else.
Wow, yeah. What are examples of parachains? Like what should exist on a parachain?
Well, I mean, anyone who wants to can, you know, a project can create its thing and bid to become a parachain. What's the sort of whole principle of one of these things is that you would want to build your own blockchain to have your own logic. Because it's easier to do that than it is to code it via a smart contract or something else.
Could you also break down different roles to those different parachains? Like maybe, I think I used to hear this idea of like, could one of the parachains focus on storage or stablecoins or something like that?
Absolutely, yes. We hope so. We hope to have all those things in the system, and they're probably going to be on very specialized parachains in order to.
So the first parachain that's launched on Kusama, which will also be the first parachain that launches on Polkadot eventually, it's called State Mine on Kusama and will be called State Mint on Polkadot. It's basically a reserved backed asset parachain, and all it does is mint assets with some sort of reserve. So Tether is going to be deploying on it. They might be the first deployment on Kusama and then on Polkadot also, but there's no smart contracts there. It's basically just governance over reserve-backed assets, and then you shoot them elsewhere in the Polkadot ecosystem or over external bridges to other networks as well.
You just mentioned Kusama.
Yeah.
We didn't actually introduce what that is.
Yeah.
We maybe want to say what Kusama is. You're a fan of Kusama?
Big fan of Kusama. It was the first network that I was participated in launching, and it was a good chaotic trial run for Polkadot and made Polkadot very boring. So that's basically the premise of Kusama is this canary network, a real value-bearing network, but a place where we potentially ship unaudited code to give ourselves a real-life experience with this technology in the wild before we then deploy Polkadot, the same technologies on Polkadot, which to date, knock on wood, have been quite boring because we've had the expected chaos of Kusama to get our training wheels off.
Right, and the technology we can run on a test net. I mean, what Kusama gives is it has the same incentives as we'll have on Polkadot. Just more experimental technology, and that's the differentiator. Kusama will have the cool tech first, but Polkadot should hopefully be stable.
One of the big pushes was for the original reasons we wanted Kusama right, and maybe you can talk about this, is like it's impossible to test proof of stake economics without real stake.
And it's not just proof of stake, and on Kusama, yes, things are broken on multiple occasions, but the governance has been amazing at fixing it, and it all just works. Yeah.
But you're also testing the governance on Kusama, right?
Yes.
Like this is all the sort of modules come out first.
We got
there.
no kill switch. We have no master key. It has to be voted on by the community.
We designed these protocols, and it's amazing to see that it actually worked and it's functioning. Yeah, I'm on the Kusama Council, and I've been watching very closely the governance.
The ZKP is too.
I've never been on any council. I'm completely unbiased.
Okay, so Kusama, let's give a little bit of a timeline for this project. Polkadot is maybe the more famous. It was like the first. It was the name that was used from the start, from the sale, throughout the time, and then but Kusama actually launched first.
A year ahead, basically.
Yeah. So what time frame are we talking? I actually know this, but I'm asking you.
Where frame are we talking for?
Kusama launch, Dot launch. I want to know a bit of the time frame that Polkadot to now.
Yeah. So Kusama launched in summer of 2019, correct?
Cool.
And then about a year later, summer of 2020, Polkadot launched.
Yeah.
And now we are about a year from that, and Parachains are launching on Kusama and Polkadot. So the launch process, it's alone for these networks. If you include the early launch of Kusama as part of Polkadot's launch, which we do, right? It was that technology running in a non-testnet environment for the first time. The launch alone has been like 2.5 to 3 years, following on 2 to 3 years of development work. And I think Gav said this in the Polkadot Decoded interview, or Barstool chat that Al was a part of as well, that compare that to the development of Ethereum 1 with him and very few sort of key core devs around him, like that was 5 days of development.
Whoa.
And this has been 50 plus high quality devs and researchers working for 5 years straight to get these things off the ground. So
now, what had launched in 2019 and last year for Polkadot, that wasn't Polkadot total. That was one thing. What was that?
So the relay chain for Kusama and then Polkadot launched.
Yeah, and the relay chain is the relay chain a blockchain?
Yes.
Yes.
And what
it just doesn't do the normal things that blockchains do. It's a layer 0 more than a layer 1.
It doesn't do a lot.
Yeah.
It does many of the things a blockchain does. It does more than Bitcoin.
It does more than Bitcoin, but it does less than it's not a platform where you can write smart contracts on top.
It's not necessarily a settlement layer either, right? Like Ethereum 1, eventually, like balance transfers for DOT tokens, we imagine will be on a Parachain as well, so that
cool.
Al can talk about
everything we can get to Parachain.
Wow. You're going to push that out too.
Staking, but that's tricky. No time frame on that one.
Maybe future. Okay, I'll see if we can get back to it. Okay, so yeah, what had launched in 2019 and then last year was this relay chain, but at the time, no parachains connected to it. So it literally was just a proof of stake module, no smart contracts. But now, as you've just said, parachains are now coming online, and Kusama's where it's starting. Mm-hmm. How many are there as we record this?
We have 4 public auction slots that have been allocated, and then 1.
Is it 5 today?
We've had 5.
Is it official? Is it Bifrost that's gotten the last slot? So now we've done our 5th plus the first common good chain. So there are 6 parachains on Kusama. Very exciting.
But are they on? Because I know that first there's the crowd loan that's usually happening. So this is where individuals can loan the parachain funds that then get used to sort of pay for this auction. Kind of. I know it's not really like rent this auction spot. And actually, those tokens come back to those users. But like, there's a crowd loan, and then there's the actual auction. So crowd loans, there's 5.
There have been 5. Yeah. Well, there have been many crowd loans. There have only been 5 auctions. So I think something like probably 15 to 20 parachain candidates have opened crowd loans to raise funds to secure their slot in an auction.
Cool.
5 of those have been successful in an auction. And then once I think there's going to be a short period after this initial 5 where some optimizations are put in, and then like the normal cycle for parachains on Kusama will run in perpetuity after that.
Could an individual chain just amass enough tokens to just buy their slot?
Yes.
That is a thing.
Of
I
course.
feel like that was what I originally thought they would do.
They probably will. Yes.
You think that could happen?
Right now, private bidders could have bid in the Parachain auctions. It's just that they can't compete with the public.
Yeah.
And the only way the public can currently enter things is through crowd loans. But when we have Parachains and they have their own logic, Parachains are going to be able, people are going to raise money on Parachains to bid for different Parachain slots and things like that.
Oh, wow.
And there will be, who knows?
Is there sort of, right now it's on Kusama, and as mentioned, Kusama is the test sort of canary network for Polkadot. But is there like a limit? Are you expecting like the number of parachains? Are you going to try to max it out on Kusama right now to see like, does anything happen? I guess maybe you've already worked out if something could happen.
Well, we want to be cautious, even on Kusama. Like, the test net, we want to scale it further. And we don't know where the limit is yet. This is true. I think there's going to be some technological limit we're going to hit on Kusama at a relatively small number, and then we're going to spend times getting around it, and then we're going to scale to maybe 100.
Cool.
Yeah. There's this misconception that goes around sometimes. I see it less and less, thankfully, but this idea that like, oh, there's only 100 slots, there can only be 100 projects on Kusama or Polkadot, which is really the wrong way to look at it. Like, these are all their own layer 1 ecosystems, so it's like having Tezos, Cardano, Solana, Ethereum 1 all in a row with all of those projects on top, and what they're getting from Polkadot is security, so they can focus on economic models and ecosystem development that isn't solely around maintaining a robust validator community to keep the thing secure. So each of these projects, some of the early ones that have launched on Kusama, Moonbeam, Moonriver, Akala's, Kusama Chain's Karura, they already have hundreds of companies, projects building applications on top of them. So that's why I said at the top, like, Polkadot is a layer 0 protocol of protocols, and that like it's hosting many of these communities in parallel.
I want to, like, the thing is, when you talk about that idea, like a relay chain, the parachains coming out of it, is there not fear that this relay chain could be a centralizing force? And what is happening? What is being done to make sure that that isn't the case?
Al is working very hard on it.
This is what you do. One of the things.
Centralizing how? I mean, if we solve the scaling problem, what are you afraid might be centralized on the relay chain?
I guess it's just this idea, like, if there was a central entity securing all of these super high value, or chain, I'm just calling agent, I don't know, thing. Could it actually, like, if it got corrupted, would that not put in danger those things? And so what is in place to make sure that, like, it can't be?
Of course, but it's more secure than any of the other things.
Right. So you say like it's a chain, it's a decentralized entity. I think it is more as like it's a network of computers. It's a computer network. It's that versus a data center that Google owns, right? Like the relay chain is to some extent providing the same sort of compute and storage resources that you would otherwise rely on a data center for. I'm not necessarily a huge fan of some of the networks that say you have to buy our hardware and put it in our data center to run our network. That's the centralizing force. But when people can actually run these things, which they can all over the place, like it's not the chain is just how the thing evolves. It's the network that is. We were scaling to the decentralization of a very large computer network.
I think the answer I'm looking for is actually the fact that you have a validator community that like is doing all of that work. So it in itself, the validators on the relay chain are the decentralizing.
Yeah, and when we talk about, again, we talked about proof of stake being 1/3, but when 50, 60, 70% of DOT is staked, that number may go down a little bit when we get Parachains on board. 20, 30% of DOT is staked in Parachains. There's never enough public float of a token for any individual to actually get to the 33% they would need to corrupt that network.
Cool. So now I think we have a picture now of this relay chain, the Parachains, Kusama, and Polkadot. We are at the cross-chain event here, and I want to talk to start about cross-chain communication between these different parachains. Does it go through this relay chain, or will it go between these parachains?
So the answer is, right now, it goes through the relay chain.
Got it.
But we have this sort of HRM people to stand for. I don't know.
Horizontal relay message passing.
Wow,
anyway,
good call.
But we certainly want to move as much as we can off the relay chain.
I see.
So the relay chain is sort of responsible for the shared security. And what that means is that we should be able to pass messages any way they can get there, but we want to authenticate them via the relay chain.
So what does that, like, so that's what it looks like right now. you would,
Yeah.
like right now you're actually passing it over, but I've heard of something called like XCMP and
Yeah.
Spree. Maybe let's define both of those and tell me where they live. And actually, do they exist or are they
Let-
still?
let's talk about XMP first.
Okay, let's start
yeah,
there.
So does it
So
exist?
these are the more advanced flavors of
now we're going-
interoperability within Polkadot, but to be clear, Kusama and Polkadot Parachains are shipping with interop from day one.
They are, cool.
Yes.
Yeah.
So XCMP is exactly the mechanism to get so that you don't have to pass things via the relay chain. Or rather, because we authenticate by the relay chain, the idea is to pass the minimum amount of data possible to the relay chain in order for us to say that this is what we should have received on the other end.
How
And
does
then we
it-
get the data.
Is it sort of like, would it be like clients where a certain protocol that like lives on all of the parachains that allows them to know exactly that this is a message and what to do with it?
More or less, yes. It's very much related to the sort of stateless validation, where the validators are a light client of the. So what happens with the parachain blocks is the validators have to validate them despite not having the state for the parachain. So we just end up passing a lot of Merkle proofs of what happened. And for XCMP, it's now we're trying to prove that something that a message was passed to the relay chain, and this also involves some light client proof to get to the thing we put on the relay chain, and then there's some more proof from that to the actual message.
Is there isn't another agent though. It's not like there's another bridging
Relayer sort of thing.
relayer. There's not like some entity in there.
No,
they are talking directly to each
The
other.
collators and the validators should all be talking to each other.
Okay.
Yes.
And actually, collators is something we didn't really mention there. What is a collator?
Right. So it's
We're doing all of it. We're
so the
covering the
collators
whole
are the
story.
people that produce parachain blocks. They're sort of, like the validators or the other agents on the parachain level. They're full nodes of a parachain, and they're responsible for creating blocks by whatever mechanism the parachain wanted. But then, when they produce those blocks, they then send them to validators of the relay chain who sign off on them and say this happened.
I always thought of the collators as being sort of like, and maybe the word's not meant to be, but it looks a little like glue, and it's in French. So it's like this idea of like, it is the thing, it's the agent that's kind of sticking it to it connects the parachain to the relay chain in a way and like is passing something between them.
I'm sure we were thinking more collecting, but yeah.
Oh.
That collecting transactions and gluing them
Oh,
together
a
into blocks.
collector, okay.
Yes.
Cool. Okay, there was another term that I brought up, but I actually don't know what it means. Is spree. It's come
Okay.
up, but is that second stage? Is that
So this is
different
beyond.
thing?
So when we have our heterogeneous shards, and the relay chain ensures that the code of each of these parachains is executed correctly. And this sort of XCMP says that if we get a message, then we can verify that it came from some block which has been verified by validators on the relay chain. So we can trust the other parachains do whatever their code does correctly. But each of these people will have their own governance, and they can change their code. So
They can have their own consensus eventually.
Can we trust? We can trust that their code was executed correctly, but we don't know what their code is. So why do we trust them? Because we trust the people behind them. So what Spree is an idea that we have shared code. So if we have shared code and we have shared security, they're secured by the same thing that secures us, then we can trust them as though they were us.
But what is shared code? What is that?
Right. So basically, if we have some function that something we want to ensure about other change. For instance, if we're trying to do token transfer, in between chains, I would like as a chain, to mint some tokens and to have control over this and to be sure that no other chain could mint these tokens. But I'd still like to pass these tokens to people on other chains. So I would write some code which ensures that only particular chains can mint particular tokens. And then I make that as a Spree module, and I put it on every chain.
I see.
Or it's opt-in. Any chain can then have this module.
Is it like a standard? Maybe.
It's a standard, but it's a standard piece of code. So rather than having a standard that we then have to trust that everyone's going to implement correctly, we would have shared code. We'd have a single piece of code that implements the standard, and everyone would run it.
There's some interesting privacy applications for this, right? So like everyone can share like a trust. It's another term that has been tossed about for this is like trust wormholes. I think that was before we actually figured out what the full acronym for this was going to be. But you can imagine, right, like some trusted shared computing resource in between all these parachains, giving some pretty interesting privacy layers to Polkadot as well.
So in this token example, what would happen is I would be able to give my tokens to this other chain. I would sort of send a message to this Spree module, and I'd know what would be processing this, and it would ensure that this other chain couldn't print the tokens. And that means I don't have to account anymore for other things. So if I didn't trust them, I'd have to have an account for them, and then if they were trying to pass it to someone else, I'd have to go back to the original chain. That's what happens with wrap tokens. But with sort of shared code, and I could then, pass it to here, and then pass it to there, and then pass it to there, and come back, and no one else would be able to print it, and it would all be as secure as the original chain was in the first place.
Who would write this code, though? Is this the idea that like any participant, any contributor could do it? And also, how would you make sure that that code is good?
Yes, well, of course anyone could do it. But this is the thing. We all sort of have to trust the code. If you don't trust it, you don't use it.
I see.
There would be a process to sort of register this on the relay chain. And we might maintain it by relay chain governance, for instance, in which case everyone would just have to trust that governance.
Or they could just not use it if they didn't trust it. But it's sort of like our security people, like at Parity, like if you have a plugin, like a Google Chrome plugin, they're like, if it has 1 million downloads, they're like, okay, we can trust this. It's like it's not like a trust assumption. It's like there's 1 million people that are using this, and it hasn't broken yet. So I think there's probably also going to be some amount of like that sort of like
threshold of use will. You just mentioned governance. We didn't really talk that much about just general governance. I am curious, like, and I know it's a huge topic that you're both very into and thinking a lot about. But yeah, how are all of these, like you talk about some of these like future developments, how do those things even get implemented into the blockchain as it stands? Because it's live, it's running, it's rolling. Would you have to do like full hard forks? Would you have to like incorporate this stuff? I mean, I know some of this actually lives more on the Parachain level, but yeah, maybe you can say something about how changes are even made in this ecosystem?
Yeah, the short answer is no forks. The longer answer involves the fact that you take a lot of advantage of WebAssembly, which not a lot of other protocols are, and Ethereum 2 has actually completely scrapped their plans to incorporate a WebAssembly virtual machine into ETH2. But maybe Al can talk a little bit more about why this means that we don't actually have to hard fork the chain and why that's possible via governance.
So we always had to have the relay chain is checking parachain logic. And to do that, there had to be some sort of virtual machine that had this parachain logic. And we had this idea, which eventually became called the runtime, which is probably a terrible name, but that's what we call it.
I get confused every time
I
you
like
use that term.
What would be a better, we're not going to rebrand it on this show, but.
It just doesn't speak to me of what it is.
And the runtime contains all the blockchain logic. The logic that of this ledger, which we have, which we're securing. And the relay chain 2 uses the same abstraction. It has its own runtime. And it could also, the client code could run any piece of thing in this WASM virtual machine. And we can update the runtime on chain.
And this means you don't need to have hard forks.
Yes. So the runtime, which is the blockchain logic, we put that on chain, and we have referender to change the code.
Yeah.
And then
there's
we deploy
a committee that basically does that. Is that committee, or is that the all token holders?
So all token holders will be voting in referendum for changing code. Yeah, anything that's a significant change to the protocol, it should go through all token holders.
And is the XCMP, would you need one of those types of updates to actually incorporate it, or does it not need runtime upgrade?
We voted on everything. So
to start it, yes, you would need a thing on the relay chain.
Okay.
Yeah.
We
voted on turning on token transfers. We voted on putting the first parachains up. Like, it's all on chain.
Cool.
So the client code, on the other hand, we can just change when we issue a new upgrade, but it doesn't change the logic of the chain.
Understood. And what about the parachains themselves? Like, they have certain code that they're running on. I believe a lot of it coming from Substrate libraries. Like, how do changes happen in Substrate?
So Parachains have sort of full autonomy, sovereign ability to update their runtimes, update their code as they see fit and based on the governance that they decide to implement on their parachain, right? So they don't have to use exactly the same governance as Polkadot. They could have something that's more like just a council. They could have something that's just pure democracy. Everyone votes on everything. They could have a situation in which Al is in charge of every decision on a parachain because they really trust Al.
Okay.
And whether or not he wants the responsibility, they can designate it to him and he can decide whether or not he actually wants to tell them the best course of action. But in terms of like writing code modules or palettes as they're called on Substrate, I mean, it's an open source library. Obviously, Parity Technologies, it's one of our core products, right? And we own those repos, but people can write code for it. People can recommend changes to it. People can also, apply for grants if it's something that's going to be particularly valuable to the Polkadot ecosystem as a whole. Web3 Foundation has also given grants for new palettes to be written for Substrate that would benefit all Parachain teams. So there's a lot of contributor teams out there who are writing both improvements and completely new modules for Substrate as just an open source tech stack.
What would happen if one parachain broke? Like, would the larger Polkadot ecosystem be able to help them, save them, stop anything? Or if it broke, and by broke, I mean like got totally corrupted and like was just doing bad things. Maybe something that even the people who had launched it didn't want it to do. Is there any off switch or stop switch?
Not directly.
Not
the relay
really,
chain governance could come in at any time and say it should be this. It has control over the whole system.
Over the relay chain itself?
No, not just over the relay chain. We could probably change the code of any of the parachains.
Oh, cool.
In addition, we wouldn't want to. Right, the relay chain governance is not for that, for non sort of common good, for sort of parachains in control of their own code. It's not supposed to do that routinely, but I suspect that if parachain broke itself and bricked itself, then relay chain governance would have to step in.
And here you're saying bricked itself, meaning like if it stopped,
yes,
you could kickstart it again.
Yeah, if it got to a state where it was unable, its own governance was unable to rescue it because it had killed itself.
Is there a possibility that a relay chain could become malicious to the network as a whole? I think
if
that's
it was corrupted,
right?
If it started if it
in which case
was 51% attacked in its own.
If it threatened the entire network, I would imagine there would be a network-wide referenda on the relay chain governance.
I guess you could kick it out.
This.
I mean, once the majority of DOT holders are bad, then it's pretty much doomed, and everyone has to hard fork. But the whole point is that we hope that
the one
that would not be
situation in which there
irrational.
would be a hard fork, would be the edge of edge cases, right? Like, I can't even actually really imagine what the.
But rationally, why would that happen? So hopefully the relay chain won't have any killer bugs, and we've discovered that Kusama, from Kusama's case, where we've been trying to break it, we've been pushing stuff through very quickly, often without. We've recovered from everything.
Yeah. You do it on purpose, eh? You're trying to see if it'll do something.
Governance works.
Yeah,
so
we have had situations in which a couple of the parachains on Kusama got stalled because of a lot of NFTs being minted all at once, or Bruno broke the relay chain, or maybe not. I don't remember.
That was that was people not being advised not to update their software.
But yeah, like Al said, it's actually been really tremendous to see how both using the governance and how engaged the community is to come around and actually fix problems. And in the situation with the remark and all the rest, there was a plan for fixing it. Went into production pretty quickly.
So far, everything we've been talking about lives very much within the Polkadot ecosystem, Parachains, communication there. But now I want to hear a little bit about bridging to other networks. This is the cross-chain salon that we're filming at in Paris. And so, yeah, I'm just curious, like, if a project, if there's a bridge protocol, something like IBC or Optics, if there's these, like, maybe individual bridges, what do they actually bridge to? How does bridging work in and out of the Polkadot world? And maybe the answer is multifold, but
So with Polkadot itself, if you're doing a bridge, the ideal situation with bridges is to have both sides understand the other's consensus. And in Polkadot's case, even if you're bridging to a parachain, that means understanding the relay change consensus. We have substrate bridge project. We can bridge from substrate to substrate.
parachain to parachain.
Understanding each other's consensus in this case. Well, yeah, okay. I
Oh,
don't
no? Oh, you're
Yeah,
thinking
we can also do relay
substrate
chain.
alone.
We
like
can
a
also
s-
do relay chain to relay chain. We can do, yeah.
Oh, yeah, but so it could be like standalone substrate blockchain not connected to Polkadot at
Yeah,
all
that-
to a parachain.
That can connect to a parachain or to a relay chain. Relay
it.
chains can connect to each other. There'll be a Kusama Polkadot bridge, which will probably be the first deployment of this technology.
Whoa. Crazy.
We also, we've been paying, we're involved in teams who are building the, bridges to Bitcoin and Ethereum. The Ethereum bridge likewise involves understanding, trying to show to Ethereum in an extremely resource-contained environment what is happening on Polkadot in the Polkadot consensus.
Yeah, and key here is like whether it's a project that's being supported by Web3 grants or generally a bridging project that we're excited about. It's fully trustless, light clients on both sides, and depending on how things go with getting these up and running in the next couple weeks and months, Kusama will potentially likely be the first protocol that has fully trustless bridges to Bitcoin and Ethereum.
Cool. That's exciting. That's a future thing to look
There's
for.
no
I
one
guess?
else that would have it in the near term, right? There's no
Neat.
really truly trustless solutions on Ethereum today. So yeah, it will be exciting to see that live.
Nice. Yeah, how do you sort of see the Polkadot world existing within the larger, like, blockchain world? Do you imagine a lot of, I don't know, like, back and forth, looking into other chains, reacting to chains that maybe live off of Polkadot, within Polkadot?
Yeah, I think the glue word you used earlier is a good one. I would imagine Polkadot being the glue for many of these networks. So wherever there's a lot of users and economic value and utility for people, Polkadot will play some sort of role, either connecting technologies or securing the technologies. Really, like the glue for Web3.
So yeah, tell me, like, I think that's one kind of future vision, but like, tell me a little bit about the future of the protocol. Like right now, as we sit here, like parachains are starting to come on board, but like, what's next? When do dot parachains happen? Huh? Tell me.
That's a long story. Yeah, so I mean now we should focus on scaling, right? We need to get these numbers up. At some point it's going to slow down, and then we're going to have to fix stuff, and then it's going to go back again. I mean, we're aiming for 100 parachains per relay chain. After that, we things will get fun. We will have to have sort of multiple levels of chains. We have vague plans for that. It's going to, we are going to be able to scale way beyond 100. I would think in the end, it all depends on,
Cool.
Yeah. And Gav wrote a little blog post, some release notes when we first launched Parachains on Kusama. So like we said a little bit earlier, we are through the first 5 on Kusama. We're going to do a little assessment, do some optimizations, and as was noted in that piece, we hope that there wouldn't be very much delay between the first 5 on Kusama and then seeing the first Parachains on Polkadot.
Wow.
So
That's very cool.
some amount of time, hopefully not that long.
Nice. I have one last bridge question since we are here, and that's okay. If you have an EVM, this is very specific. If you have an EVM compatible parachain, and you have Ethereum, and you build a bridge between those two things, do you still have to know the logic of the relay chain, like you had said, or could you deploy smart contracts on both of those that live outside of it?
So in order to bridge to Polkadot, in order to prove something happened on a
But,
parachain,
like, oh yeah, on a
you
parachain.
have to follow the logic of the relay chain.
I see.
So you have to have an EVM thing that's following the relay chain.
It's the relay
which
chain.
of course we do.
I see. Okay, cool.
Right? We have that. Snowfork have pretty much built that.
Yeah.
Got it.
They're here
Snowfork.
today, or this week.
Cool. Yeah. Well, I think I've asked all my questions. We're here on a very hot day in Paris. I think it's been a really fun time here at ECC. I hope you're enjoying yourselves as well. Thank you
Yeah.
so much for this interview and going through all of this stuff. I mean, I've
We
been
could keep
wanting to
going
ask.
for hours.
Yeah, I've been wanting to ask some of these questions. Some of them I already knew. Kind of wanted to do it for the viewers, but also some of them I didn't. And I think especially the bridging messaging, that's the space that I want to explore more.
Yeah.
Cool. So thanks so
Awesome.
much. And thanks for watching.